This is a pretty long question with multiple steps, and when you learn the potential divider equation, you can reduce the number of steps to solve this question, but I will solve it using Ohm's law. So the answer to this question is B. Double check answer. To solve this question, I will first redraw the circuit so that I can see the connections of the three resistors very clearly. So I've labeled my three resistors A, B, and C, and I will redraw the circuit like this. You can try tracing the path of the current as it comes out from the battery. It moves past resistor A, and after the current passes through resistor A, it will split to go into two different paths, passing through resistor B and C. So now it's very obvious that resistor A is connected in series with resistor BC. Resistor BC, two of them are connected in parallel with each other. Okay, so the strategy for this is as such. Notice that I didn't draw in the voltmeter because to simplify our circuit diagram, we can always remove all the meters and just label what is the value that the meters give us. So in this case, the answer that we're looking for is the voltmeter reading of the BC parallel branch. So I have removed the voltmeter in my drawing and replace it with a label of the voltage across the parallel branch. The strategy here is to look at the whole circuit to find currents, which is what I've written in blue. We can find current using Ohm's law by using the total voltage, which is the EMF of 12 volts, divided by the total resistance, which we have to figure out in a while. After we do this, then we move on to the green steps, the steps in green, which is to use the current value to find the voltage across resistor A. We can do that also very easily using Ohm's law. Then finally, if we know the voltage across A, then we know that the sum of all the voltages, the sum of the voltage across A and the voltage across the parallel branch, together it should add up to 12 volts. And that's how we can find out what is the voltage across the parallel branch, which is what the question is asking for. So the first phase, I will write this down in blue. I will first try to find out the effective resistance of the whole circuit, which is the resistance of A, 10 ohms, plus the resistance of the two resistors in parallel, B and C. You can do your workings at the side. The resistance of the parallel branch, when you connect two resistors in parallel, is 5 ohm. So together, the total resistance of the whole circuit is 15 ohm. And on the whole circuit, apply Ohm's law, V equals IR. So rearrange the circuit, make I the subject, and you can figure out that the total current passing through the circuit is 0.8 amperes. Second phase of our solution. So now we have current value known, 0.8 amperes, passing through the whole circuit and also passing through resistor A. We can now use Ohm's law on resistor A to find the voltage across it, and we got 8 volts over here. And the last phase, to get the final answer, the sum of the voltages, because A and BC, they are connected side by side, they're connected in series with each other. So the sum of their voltages must add up to become 12 volts. And using this equation, rearrange the equation, we realize that the voltage across the parallel branch must be the balance value of 12 minus 8, which is 4 volts. And that's how you can get the answer.